All right. Okay. Our we have a few more topics to cover in chapter 3, and we'll be done with that in short order. And then we'll start chapter 4. Okay. Now, when we deal with really, really large data sets, we have lots and lots of data, millions of records, then that poses a particular challenge when it comes to visualization. So what will happen is quite a lot of points may fall, especially in a scatter plot, lots of points may fall in the same place, same point, same coordinate. Okay? So you don't really get an idea about how densely the data points are packed. So many observations may fall in a single point, many observations may cluster too tightly together, and we may not really understand how densely the points are packed in particular regions of the graph. Okay? So we have to do something about it, and one possibility is to not look at scatter plot like diagrams. Instead, you look for general histogram or box plot type of charts, which give you the general idea about the distribution and really does not deal with the actual individual values. Or you can take a random sample and then plot that, and of course when you do that, then you need to be careful that the sample that you take truly represents the entire data set, and that could be a problem. Then a couple of other options is to reduce the marker size, the marks that are made, and then you can not have any the points have background or painted completely, so you can make it translucent. There is an alpha parameter, alpha equal to a value that will make the points more translucent, or even just the border alone and nothing inside. And those things can mitigate the problems. But one thing that can be done, which is not widely understood, is what is called jitter. Okay, so that's what we're going to look at now. Jitter means that when you have lots of points falling in the same place, you add a little bit of error to the points. Okay, so that way they are separated by a micron. So you'll get a better picture. So that's what jitter is. So we're going to look at a larger database. Right now, the housing.df has only 506 observations. So you're not going to see sometimes how densely these things can get when you have larger data sets. So for just this example alone, we will look at the universal bank data set that has like 5,000 observations. So let's go ahead and read the data into, and I'm not going to have strings as factor. So we just read the data. Okay, so instead of Boston housing, so we will have universal bank. Okay. All right, so once you read that in, okay, then we will plot a scatter plot like normal. Okay, so ggplot, the data is universal df, okay, and then AES is x equal to income, y equal to CCAVG. Okay. I'm using the same column names as in your textbook. Okay, and then we will differentiate third column, securities account. So the points will be colored differently. Okay. 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 And we're going to do a geom point. Okay. So here we have the scatter plot. Okay. Now you see that there are a lot of points bunched together here as opposed to over here. So we can try to expand this area, okay, by doing what? What can we do to expand? Log. So you can use logarithmic scale. Okay. So we can do scale. We did this last time. Scale x log 10. Okay. And then we can give breaks. What are the breaks we want? I have to say breaks. Breaks equal to C 10, 20, 40, 60, 100, 200. Okay, so that expands this region of x-axis. Yeah. Yeah, well, you can, you need to say data equal to the data frame name and then mapping equal to AES. That's the regular syntax. But you can omit it and R will fill it up. So, yeah, it's like a slang. You know, it goes without saying that is mapping. Yeah. So, I mean, yeah, theoretically, you're right. I need to say mapping. I'm just taking a shortcut here. Okay, so and I can, to have this scatter plot span the entire width, I can bring this legend for color down here by placing theme. So there is what is called legend position. Legend position. So we can say bottom. Okay. So the legend position is part of theme. So that will put that legend position back down here. Okay. Now this one is without any jitter. Okay. This is the regular scatter plot. Now if you want to add jitter, so like you can see there are a lot of points here that are coinciding in the same coordinates. So I'm going to copy paste that chunk, okay, and then change. So all I have to do is instead of geom point, we use jitter. Geom jitter. Okay. So that's that. Okay. I don't know. Maybe I'm a little colorblind or something. I don't see a whole lot of difference, but sometimes it can be of help. Now we could probably, if we can put these two charts side by side, maybe we can see a difference. Okay, so how do we put these two charts side by side? Well, we have to use what? GG, what is that? Grid or grid extra, right? So, well, we have to, let's see. Library grid extra. So we have to run that. And then, of course, we need to save these two. So let me copy paste these two graphs down here. Okay, after grid extra. Okay. And we have to save it, right? So let's save this in P1 is the first plot. Okay, and I'll copy this code, which is geom jitter, as a second plot, P2. Okay. Okay. So once you've saved the two plots, then you can use grid arrange, right? Grid dot arrange P1, P2, and then is it row equal to 1 or rows equal to 1? I forget. Somewhere. Well, we'll try both. Say rows equal to 1. If it gives an error, then change it. Okay, so that's wrong, I guess. Row equal to 1. Or is it n row? Maybe it is n row. Yeah, n row. I don't know. Maybe. Yeah, n row equal to 1. So now you see them side by side. The first one is regular scatter plot. The second one is with jitter. Frankly, I can't see anything different. But this is a tactic that you can. This is a tool that's available. You know, sometimes it's helpful, sometimes not. And in this case, I frankly can't see any difference. Yes. Scroll up.